All right, everybody, we're going to get started, even though it's, I guess we've only gone over 2 minutes. But this is going to be a really dense, hopefully really fun session for everybody to be involved in. So my name is Steve Gomez. I'm a research scientist at MIT Lincoln Laboratory, where I study visual analytics for cybersecurity and HCI. And I'm a program co-chair. My other co-chair is Sanchari Das, who is from the University of Denver, and she's not here in person at Viz, but she'll actually be moderating the panel session that we have after the lunch break. So you'll get a chance to meet her. So let's get started. This whole block is about papers. We have a paper track that includes, as both Chris and Jordan were saying, full papers, short papers. There are position papers, which we didn't have any submissions this year. And we're going to go through the 5 accepted paper presentations during this block. So we have 3 in-person presentations, one of which is a short paper presentation, and then 2 virtual talks where we'll hear a pre-recorded video and then pull up our authors on Zoom and have a live Q&A for a couple minutes for each of those. So I do also want to use this time to announce our Best Paper Award. We select the best paper every year with a jury that looks at the accepted work in terms of the potential impact, the contribution, and also sort of that overall presentation quality of the manuscript. As Chris said, a lot of these submissions will get promoted into TVCG articles later, so that's really important too. So with that, I want to announce that our Best Paper Award this year goes to Visual Firewall Log Analysis at the border between analytical and appealing. And this was work at Fraunhofer IGD by Maria Schufrin, Hendrik Luktiek, and Jorn Kohlhammer. So let's give them a round of applause. And a keen observer will note that this is one of our pre-recorded talks. So we're going to be a little bit unconventional in this session. Normally we kick off the paper session with the best paper presentation. But we're going to actually save this to be the final presentation so that we can have all of our virtual talks at the end. And that'll be some incentive for everybody to stick through the session and see all of the fantastic work that we have. So with that, let's get right into our in-person presentations. So why don't we have Adrian come up here and sort of get ready to present. What I want to remind everybody is to please use Slido to submit your questions, both in person and if you're watching online. But let's do this. If you're in person and you want to speak at the mic, still use Slido, but make a note that you're in the room, and then you can go right up to the mic and try to call on you. So that way we can make sure we're using all the media that we have available to us. And with that, why don't we have Adrian come up?
So hello everyone, my name is Adrian, and today I will present the paper with the title Analysis of the Design Space for Cybersecurity Visualizations in VizSec. This paper I made in collaboration with my colleagues from University of Zagreb. To start off this presentation, I will tell you something about my motivation for this work and what was the goal of this research. And after that, I will present you with a meta-analysis of existing survey works in the domain of cybersecurity visualizations. After that, I will present you an analysis of the components of visualization design. So for each component of visualization design, I will tell you the details of how we made an analysis and what are the results of this analysis. And at the end of this presentation, I will tell you something I will present you a brief summary of today's presentation, and I'll tell you our conclusions from this research. So our motivation for this research was to know how are visualizations typically created in cybersecurity. So that was the first question. The second question was what areas of the field, of cybersecurity field, are rarely explored and are open for further scientific research. So the goal of our research was to analyze the design space in the created visualization systems from VizSec research papers. So to start off, we first found 17 survey papers in the field of cybersecurity visualizations. And all these papers you can see on the table on this slide. And for those papers, we made categorization by area of interest within the domain of cybersecurity visualizations. And from our analysis, 6 focus areas emerged that are visual encoding, input data, use cases and applications, tasks and challenges, and evaluation and interactivity. So on this table, you can see all 17 survey papers listed, and it was indicated for each survey paper to which area of interest it focuses on. And we can see from this table that the largest focus in these survey papers was on visual encoding and input data, and the least focus was on evaluation and interactivity areas. So after this meta-analysis, we made an analysis of the components of visualization design. So we choose 5 different components that are input data, security tasks, visual encoding, interactivity, and evaluation. And we made analysis on the basis of 60 VizSec research papers dating from 2016 to 2021. So for input data, we made categorization based on 2 things. So first thing is what type of input data was used, and the second thing is what is the fidelity of data source. So when it comes to the type of input data used, we've seen that the most of that input data came in form of logs. So whether network traffic logs, DNS logs, events, or alerts. And also malware samples, executables, and source codes are frequently used as input data. And we also seen that personal data in many forms are also often used. And the fidelity attribute tells us whether some input data came from real-world data source or some artificially generated data source. And from our analysis, we concluded that over 80% of the works from VizSec use real-world data sources. So for security task, we made categorization that is based on cybersecurity task that visualization is intended to help with. So at the end of the day, we identified 14 different security tasks. All these tasks can be seen on this pie chart. And we can see that there are 3 main application areas of visualization in cybersecurity. So first one is forensic analysis. The second one is threat and malware analysis. And the third one is general awareness and education in cybersecurity. Apart from these 3 main application areas, we can see that vulnerability management and user behavior analytics are also frequently tackled as a security task with visualization in mind. So when it comes to visual encoding, we first made a high-level classification that is based on the type of geometry used, so 2D or 3D representations, and whether coordinated multiple view technique was used or not. So from our analysis, the results showed that most of the works from VizSec use 2D geometry representations, and most of these 2D geometry representations use as well coordinated multiple view technique. The second part of analysis of visual encoding is a low-level classification that is based on specific visualization techniques. So the type of visualization techniques we used from D3 Graph Geller website. So this is a website that lists all the general visualization techniques that can be implemented, achieved with D3GS library. So on the graph on this slide, we can see the percentage of occurrence for each visualization technique that we identified among these works. And the results showed that the bar plot, heat map, histograms, network, and scatter plots are most commonly used as visualization techniques. On the other side, visualization techniques like density plot, arc diagrams, lollipops, glyphs, Sankey charts, and pie chart are rarely used. When it comes to interactivity, we ask ourselves, what is the goal of interaction? So based on that, we made categorization that is based on visual analytics type. So whether some visual system has exploratory or expressive interactions. So the result of this analysis shows us that around 20% of all these papers selected from VizSec have no interactions at all. And also the same amount, around 20% have expressive interaction type, and more than half of all selected papers have exploratory interactions. When it comes to evaluation, we ask ourselves three questions. So when does an evaluation take place? After the development of some visualization system or during the development of it? And how was it conducted? What are general evaluation methods that has been used to implement some evaluation? And the third question is, what are participants in the evaluation? Are they professionals, or maybe they are some non-professionals? So on the left side of this graph, of this slide, we can see the graph showing the number of summative and formative evaluations among VizSec papers by either non-professionals or professionals in this evaluation. And from this graph, we can see that in formative and in summative evaluations, professionals have predominant role. On the right side of this slide, we can see a graph showing the number of evaluation methods used by formative and summative evaluation. So from this analysis, we can see that in formative evaluation, feedbacks from professionals and interviews with professionals are most commonly used as evaluation technique. And when it comes to summative evaluation, we can see that case studies, use cases, and user studies with non-professionals are most commonly used. So to conclude today's presentation, what we did analysis of 17 survey papers in visualization security domain. And also we did an analysis and classification of 60 VizSec research papers dating from 2016 to 2021. This all gave us an indication of direction in which visualization is trending in the field of cybersecurity. Also, it gave us some further questions that we can research. So for instance, can adding another dimension, so 3D representation, can be beneficial when creating visual solutions for certain security tasks? And we can investigate what are security tasks that aren't yet supported by visualization systems. And for future work, we would like to develop a methodology for both creating and evaluating cybersecurity visualizations that are based per security task level. So thank you all for your attention, and now you can ask me questions.
Thank you. Let's see if this works. I'll stay over here and help moderate what we're seeing on slide. I've got a couple questions of my own. We do have think, just a few minutes. So the first question that we have on Slido is really kind of open-ended and hopefully hear your perspective on. What are some areas that you think are underexplored when it comes to VizSec? I suppose that could be either, the kinds of encodings and, parts of your framework, or, are there problem areas that you think there aren't a lot of tools for?
Okay, from the meta-analysis on the first part of this presentation, you can see that evaluation and interactivity areas are rarely explored. But there are some papers that cover evaluation good. But I think interactivity isn't well explored. So this is, for me, one interesting area that can be explored in future work, especially not interactivity from high level, but interactivity on the low level. So to see what interactions benefit in what security tasks. So
great. So another one that I have is, how do you think with tools like D3 that have libraries? I know when you were showing the encodings, like you had bar chart, all these different things. How do you think that the choices that those libraries make sort of trickle down to what tools actually get built here? Do you think in a way those libraries kind of constrain the sorts of tools that get made for this?
Yeah, I think so, because why I choose D3 representation from D3 library, because I saw throughout the papers that most of these implementations are using D3 library. So I think that this library really constrains us in the way that we use only some visual encoding methods that are supported and that are general in this library, and someone that are a little twisted from these general methods. But we don't really explore a new ways of visualizations. Okay.
Sounds good. All right, in the spirit of time, why don't we thank our speaker again and then invite Igor to come up.
Thank you.
Well, he's doing that. I'll ask you again. Please feel free to put questions into Slido. Come up to the mic, raise your hand, however you want to do it.
Hello, everyone, and welcome. My name is Igor Cheripanov, and I'm presenting our paper with the title Visualization of Class Activation Maps to explain AI classification of network packet captures, which was a research work along with Alex Ulmer, Jonathan Giraldi-Gewono, and Jörn Kolhammer from Fraunhofer IGT and Technical University in Darmstadt. In this paper, we combine classification of network data, adapted an explanation technique for classification model, and integrated into an interactive web-based interface. The constant growth of connections and variability of new applications in our networks makes monitoring and analysis of network traffic an important research topic for supporting the performance of networks. Our goal is to provide approaches that help experts to satisfy network requirements such as quality of service, network security, and resource consumptions. For these purposes, it is necessary to record and analyze the network data. We tackle this analysis by combining two complementing fields, such as information visualization and visual analytics, which offers the expert solutions to analyze the data interactively. These tools allow to filter the data to the most relevant parts. Then the field of machine learning that proposes automatic systems that classify captured network data. Deep learning is a part of machine learning methods that became very popular in classification tasks. Deep learning-based approaches outperformed all former proposed classifiers that also classified network data. The use of deep learning models beneficially eliminated the need to manually search for features in the network data. But there are severe drawbacks of these models. They are very complex, cost by nonlinear functions which are not interpretable. Despite the fact that these models reach a high accuracy, however, they are not understood by experts, which can lead to a limited use. So explainability doesn't improve the performance of a model. However, it is an important part of formulating highly reliable and trustworthy systems. For these reasons, we aim at providing explanation for the predictions in addition to the classification of data. Moreover, the expert might extract new insights from the classified data based on these explanations. Another important aspect that enables explainability is the evaluation of classification model. In this paper, we combine classification of the network data, adapt an explanation of technique for classification model, and we integrated it into an interactive web-based interface. Our system is an interface connecting experts, algorithms, and data, and therefore plays an important role in fostering trust in classification models. So our tool is designed for two user groups. Network experts are interested in network troubleshooting, analysis, and detecting other suspicious traffic in network. Network experts benefit most from the visualization interface, since our tool enables to view classified data and examine the explanation of the predictions. Then they can also locate relevant features from the impacting bytes in files for specific applications. And our tool enables also to compare differences in patterns of classified files for the same or distinct classes. The other group are machine learning experts and developers who design classification models based on raw data from the network and provide them to the domain experts. By using our tool, the classification model can be evaluated by network experts, and through their feedback, machine learning expert can improve the correctness of the classification model. Now let's take a look on our explanation AI system. The right sides represent the PCAP files. PCAP is a data format for capturing network data from several OSI layers. The PCAP files pass several pre-processing steps in which certain segments are eliminated or padded. In the middle, you can see our deep learning model, which is based on a convolutional neural network architecture. The main function of this model is to predict the network application class of each corresponding PCAP file. Recent research showed that convolutional neural networks performs best in classification of network data. That is one of the reasons we decided for this deep learning architecture. Convolutional neural networks contain convolution hidden layers, which conclude a set of independent multiple filters that performs convolution operations. And finally, the class activation map, which is illustrated on the left of the slide. The class activation maps are calculated to explain the predictions made by convolutional neural network for a PCAP file. A resulting class activation map has the same size as the classified PCAP file and represent impacting bytes that led to the predicted application class. For the calculation of class activation map, we apply global average pooling from the last hidden layer and transform feature maps into a single number by averaging. In this way, we produce a weight for each feature map, and then all weighted feature maps are summed up into a resulting class activation map. The advantage of class activation maps is that they are computationally cheap. A class activation map is calculated directly on a learned model in comparison to other techniques which explain a prediction by learning an interpretable approximated model locally. So on this slide, I would like to demonstrate our system. Does it work? Yeah. Our work builds on the NetGapViz tool proposed by Alex Ulmer from EGD Fraunhofer. It is a web-based visual analytics interface where experts can upload PCAP files. The user can restrict PCAP files by filtering and then send the selected PCAP files to our classification module. Our module is responsible for the classification, class activation map calculation, and visualization of these class activation maps. The interface is divided into 4 visualization elements. The packet overview on the top shows the several extracted information from the headers of the PCAP files. It contains also classification results with the class and confidence probability provided by the classification model. Then PCAP details on the left represent entire extracted information from the headers of a packet in a nested style, which can be unfolded. Then in the middle, you can see the class activation map. A class activation map reflects all bytes of a PCAP files, as already said. The colors illustrate the impacting bytes that led to this class prediction. Blue represent absolutely no relevance, and red represent high relevance. We have also different color modes. And on the right side, PCAP file is represented in the plain and hex representation. So, to evaluate our approach, we performed 2 evaluations. One for the models we used and one for the visual interface. We tested whether the performance of the models with different sizes of kernels differs, as well as how the numbers of hidden layers affect the performance. The table on the slide represents scores of different parameter settings. The performance of our model showed strong competitive results on different datasets. Other research work claimed to classify encrypted data by using convolutional neural networks as black box. We replicated these experiments. With provided explainability of the model decisions through the class activation maps, we could observe that such models do not make decisions on the encrypted parts of packets. As you can see in the picture, this picture illustrates the patterns of the extracted impacting bytes of 4 classes. The impacting bytes are on the top of the PCAP files, which is unencrypted header information. This again confirms how important explainability for understanding, explainability is for understanding which parts impact the predictions. Second, we individually interviewed experts in order to evaluate our tool and receive feedback for improvements. We prepared different tasks for the expert to test whether this task could be solved. The expert had to solve this task without any help. The feedback by experts showed that our tool is intuitive to use and raised also trust in automatic classification methods. Finally, we asked them to fill out a SUS questionnaire, which scored an average rating of 78. This implied a good user satisfaction. Thank you for your attention.
All right. Again, please post questions in Slido or come up to the mic if you're interested in that. We've got one here. So can you elaborate on the advantages or disadvantages of CAM compared to tools like Lime? So you kind of alluded to the fact that some of these explainer methods try to approximate the model. And, you know, can you say more about the advantages and disadvantages for your choice?
Yeah, CAM is calculated directly on the model which we learned. And that means that we explain the model decision which we have, and not the decision of the approximated model which are trained on local decisions of the original model, and that is the biggest advantage. And it is also computationally cheap, which was said. And I mean, if you classify a huge amount of data, then time is also very important.
Right. Yeah. Cool. So just a comment on slide OEC. Super interesting to see activation maps used on something besides images, which I think is a very valid point. Right. A lot of explainer tools get used on vision tasks. One question that I had was, in those graphs that you showed at the end, where you're showing what the significant bytes look like for different applications, is there a good way to like indicate sort of the uncertainty about these classes, or how much spread you might see? You know, in other words, like if you have two Spotify streams, like how closely do they hew to what you're showing here? If you were to go and you know, run those two different samples through your classifier.
I didn't
Does
get
that
your
make sense?
I didn't get your question.
Okay. I guess my question is, does this representation bake in kind of some of the diversity that you might see in the traffic within some of these categories? Like,
Yeah.
is it always the case that, you know, the nth byte in SCP that's transferring like a gigabyte versus a megabyte is always the same?
Yeah, as you can see here, you have different patterns in among the classes. For example, Gmail, you can see that it has not the same pattern like in comparison to Vimeo. If you speak about the patterns among the files, I mean, you could of course deep into inside the packets and examine which ports and which information is under these bytes. I mean, which information are hidden behind these bytes, then you will see much different patterns. The patterns will be more different than maybe. What I want to say, even if you have very similar patterns, the content should be not the same.
Right.
For each class.
And I think we need to switch to the next presentation. But while, we have our new speaker coming up, I'll just quickly say that, someone has asked, I think, a question related to this. They say, is it possible to aggregate multiple packets directly? Which I guess gets to the point of, you know, differences.
Yeah, it is even an aggregation. It is an average of several cams for a specific class.
Makes sense.
Okay, thank you very much.
Yeah, let's thank Igor. So do we have Kuhu?
Hello, everyone. I am Kuhu Gupta, and I work as a data visualization engineer at Illumio. Illumio is a network security company that helps enterprises segment their networks to write better policies for making the systems more secure. Today, I'll be talking about a hybrid tree and network visualization technique for segmentation. I'll be briefly covering background, followed by design process of Portola, then wrap the presentation with discussion and conclusion, and finally answer any questions. Today, 60% of the organizations lack visibility into their network. Lack of visibility is a significant obstacle for security teams implementing threat detection and investigation practices. However, this is a great opportunity for visualization researchers. At Illumio, we protect our customers by restricting attackers' lateral movement and reducing the attack surface with a granular control through microsegmentation. You can think of it as a submarine having a compartmentalized structure. If there is a breach, it will remain contained in that single compartment. In the context of our IT environments, segmentation breaks data centers and cloud environments into smaller segments. Segmentation has traditionally been based on IP addresses, but newer products are using labels and tags to increase flexibility and improve simplification. Human-readable labels like workload's name, workload's role, and stage in the development cycle. These multidimensional labels are attached to workloads to build a contextual network. This becomes the basis for building and testing policies to allow or block the traffic flows. Currently at Illumio, we guide our customers to use 4 labels for relevance and manageability. Those are location, environment, application, and role. However, our policy engine can provide large number of labels if needed. So each source and target node in a computer network can have any of these one or more segmentation labels. Different types of label hierarchical organizations can be built to form a contextual network. In this paper, we use single hierarchy organization. The traffic between any 2 nodes is through ports, and 2 nodes can be connected through multiple ports. This is a snippet of the traffic flow data. Each row is a flow, which has source IP, target IP with its associated labels, as well as port protocol information on which source and target can talk. Inside a security team of an organization, people perform different tasks as a part of their workflows. Application owners define security policies on an application-by-application basis. The risk and compliance officer analyzes system-level security policies to protect sensitive information by access control. An auditor conducts traffic flow audits to ensure compliance to information security policies of their organization. After identifying users and user tasks and reviewing existing microsegmentation and Illumio tools, we synthesized 4 essential design requirements to inform a final design. An overview is an essential segmentation task, as it helps to understand the network topology and identify critical patterns. Users often have to do exploratory analysis where they are not sure of what they are looking for in the network. After users have identified an item of interest, such as a high volume port, they want to see that in much more detail and in isolation. Critical core services, for example, Microsoft Active Directory, are the ports where the number of connected source nodes are significantly higher than target nodes. Visually identifying these core services is an important task. Users want to identify anomalies in the connections and visually explore many-to-many and one-to-many relationships within the network. The design requirements and few precursor designs laid the foundation of a final design called Portola. And let's delve deeper into it. So Portola uses an outward in-tree radial layered visualization layout where the root of the hierarchy faces outwards and levels below the root go towards the center. Each label has certain nodes under them, as each node has its associated labels. This forms a hierarchy, which is captured in the visualization. In the first image, role label Iostova is selected on source side. You can see the parents like HQ and staging being highlighted. Secondly, the target nodes and its labels connected with source label are also highlighted. In the second image, on selecting a source node IP address, one can see its associated labels, as well as all the connection with nodes on the target side, as well as port 3306 they are talking to. Portola's network view connects the leaf nodes of the source and the target side of the hierarchy through the ports to present an overview of the network. The ports occupy the space between the 2 semicircular hierarchy sectors. The size of each port is mapped to the total number of unique connections passing through those ports. With the size encoding, it is easier to spot the ports with the high and low volume of connection, which helps find anomalies. The position of the ports is determined by X and Y forces. The positioning force along the y-axis is based on port numbers. So the lower valued port like 223306 would be on the top, and like 8983 would be on the bottom. Additionally, port nodes are positioned along the x-axis based on the number of the in degree and out degree of the ports. If a port connects to more source nodes than the target node, the port will move towards the direction of the source nodes. Horizontal position of the ports facilitates analysts to identify core services of their network. Let's talk about some key takeaways. From our domain collaborators, we learned that splitting the information into multiple views wants the analyst to stitch together a cohesive view in mind, which can be error-prone and can lead to mistakes. Network data changes with time. Therefore, we want to extend Portola's layout to effectively show the change in the network, as well as the hierarchy structure between two timestamps. The proposed layout is not tightly coupled with the domain. For example, in a geographical data set, entities such as cities, states, countries can be organized hierarchically to gather additional context. And it is possible to have relationship between these entities. For example, flight routes between cities. To conclude, Portola has been successful in aiding network analysts to audit network connections, identify anomalies in one cohesive system. Users can identify core computing services on these ports through the port view. Portola's layout also supports uncovering the network topology and analyze connections between the highest level and the lowest level of hierarchy in the network structure. It also facilitates drilling down on elements of interest while viewing the entire network topology and not losing context. This paper discusses design principles that broadly apply to design network security visualization and other domains which have hierarchical and network data. We believe this research could be a stepping stone for the next generation of visualization techniques for network segmentation. With that, I conclude and happy to take any questions. Thank you.
So I think we only have time for one question. I don't see any in Slidos, but I've got one for you. So there are a lot of new network technologies that are virtualized or software-defined networking that have the ability to enforce these kind of logical security policies that I know you talk about in your paper. Mm-hmm. And I was just curious if you thought about your visualization as a potential interface for authoring policies that could then get enforced in the network.
Yeah, so I guess that is what we are planning for the next year, is using this tool and integrated an interface to facilitate that. Like, since you can also identify vulnerabilities, like mapping vulnerability data on top of it, so that it's much more easier to identify for which ports or which sectors we need to write policies for. So yeah, that is definitely in the plans.
Awesome. Let's thank the speaker again. And with that,
Hello everybody. Today I am going to talk about our paper preview, a visual analytic workflow for the proactive risk inspection of open data. So first, let's see what are the different risks for the open data ecosystem. So open data, even after they are anonymized, can be vulnerable to disclosure risk. For example, let's consider one individual level traffic stop and search dataset and another individual level police citation dataset. Both of them are anonymized. But when they are joined with common attributes like age, gender, race, address, date, then we found that this individual was stopped at 2 a.m. and was later cited for the possession of narcotics. So this can be an example of identity disclosure. Another example, even aggregated level records can be vulnerable to disclosure risk. For example, in this county record, there is only one record for a 26-year-old female Hawaiian staying at this zip code. If this is joined with another individual level mobile clinic record, then we can find that this individual has this disease. So this is also an example of attribute disclosure. Now, let's see some more such examples. So researchers were able to re-identify the details for 91% of all the taxis running in NYC using the anonymous taxi data and an external medallion dataset. In another example, individuals were re-identified from the de-identified medical records released by the Australian Department of Health. So the key questions are, will a de-identified open data leak sensitive information when joined with other datasets? And if yes, can visual analytic tools act as a data confidant and data informer to ensure continuous privacy protection? In order to answer these questions, we first started with the red teaming exercise. So here, we collected dataset from 496 data portals with around 200K data resources and around 40K datasets. We filtered them based on the datasets which have some kind of quasi-identifiers. And after removing some of the false positive and non-English and irrelevant datasets, we had a seed collection of 426 datasets. From this seed collection of datasets, 151 datasets were of individual level records and 275 were of aggregated level records. So this is the distribution of the quasi-identifiers in them. As a part of this exercise, we first exploited the vulnerable entry points into the open data ecosystem, where we found examples of datasets with very few records for a particular combination of quasi-identifiers. Next, we explored the dataset joins, where we tried to join different datasets and found examples of identity and attribute disclosure. Based on this red teaming exercise and in collaboration with our data privacy experts, we developed the Data Defenders workflow in Privy. In this workflow, we first collect privacy-related datasets from the open data ecosystem, then use weighted clustering in order to triage the joinable groups, which is followed by comparing the joinability risks between each pair of datasets in a cluster, which finally leads to the identification of the cases of disclosure using record level matches and feature suggestions. We also developed a set of visual analytic interventions in each step of the workflow. For example, while triaging the joinable groups, we tried to visualize the risky cluster signatures. So here, suppose here we have 3 clusters of datasets, but only 2 of them have privacy relevant attributes. So these clusters are ranked higher in our interface. Next, we rank the dataset pair by their risk and the relevance and try to explore and explain the pairwise disclosure risks for this dataset. This is followed by the evaluation of the sensitive information at the record level by analyzing the join outcomes. Now let me walk you through each of the steps and how we implement them in the Privy interface. So first, this is a group of highly joinable datasets in which all of them have the gender and race attribute, but none of them have the age attribute. This is another such group of cluster which has no privacy relevant attributes. So the previous cluster would be ranked higher than this cluster. Now the next step is to compare the joinability risk between pairs of datasets. So I am going to walk you through a case study that we developed with an university researcher. So the researcher first selected some of the privacy-related attributes which are generally used in the police dataset. Then he analyzed the risk score distribution and found that some of the dataset pairs have high risk score. He selected one of such high risk pair and tried to join them based on the suggestions automatically offered by PV along with the location attribute. On joining this dataset based on this attribute, he found that there are only 40 common records between these two datasets, which can be explored using this visualization. But using the feature suggestions offered by Privy, he further observed that there is only one record which was opened in 2015 but was closed in 2016. On further inspecting this record, he found that this is a case of a female runaway juvenile which was reported at this location on this date and was later closed to a supplemental report 1.5 years later at this date. So this is an example of identity disclosure despite the location being partially masked. Now let's see a short demonstration video for the interface. This is the default landing page for Privy. Here you can filter the dataset by the tags, the granularity, the data portals, and you can also select the different privacy attributes. So if you use the default filters and click on the search button, it shows the cluster of datasets on the left-hand side along with the explanation for the formation of these clusters. For example, the datasets in this cluster have the gender and race attributes but does not have the age attribute. If you select all the datasets from this cluster, Privy will load all the possible pairwise combinations of datasets on the right-hand side. These dataset pairs are sorted based on the risk code, and if a data defender selects this dataset pair, then Privy automatically suggests some of the joining attributes. And if we join this dataset pair based on these attributes, then we can explore the common records through this visualization. Here we can see that there are 162 records for individuals of age 45 and race white. But if we enable the vulnerable record switch, we can see that there is only one record from the age 73 to 87 to the race white. On inspecting further details, we can observe that this is the record for a 76-year-old white female who was arrested on this date for larceny at the neighborhood dunes and the petrol zone 110. We also have the exact GPS coordinates for this incident. Thus, it becomes easier to pinpoint an individual from this record. We can argue that this is a step towards identity disclosure. Privy also offers some feature suggestions to further explore this record. Now, if you select a different cluster, then all the possible pairwise combinations of datasets from this cluster will be loaded on the right-hand side. Moreover, using this switch, you can also explore the vulnerable dataset in each cluster. So this is a short demonstration for the Privy interface. So as a future work, we are trying to characterize the utility of this joint dataset. We are also trying to explore the joinability risks beyond a pair of datasets, like 3 datasets or 4 datasets like that. We are also working on increasing the number of datasets available and also trying to gear the interface more towards the data subjects. So this is a presentation of our work PV. You can access the interface out here and read more in our paper. Feel free to contact us if you have any questions. Thank you. Hello, everybody. Today I am going to talk about our paper, Preview, a visual analytic workflow for the proactive risk inspection of open.
Hello, Kostov. Can you hear us? Can you hear us? We can't hear you, I don't think.
No, I cannot hear. I can still hear the presentation.
Okay. Can you hear us now? Oh.
I can still hear the presentation going in the background. Can you stop the? Yeah, now it's good. Yeah.
Can you hear us okay now?
Yeah.
All right. So again, I'll read a question. If other folks have questions, please add them to the Slido or come up to the mic. The first one is kind of a classic in cybersecurity, which is, if this tool fell into the wrong hands, do you think that attackers could use it to make their efforts to breach the privacy worse? Are you guys concerned about that?
Yes, kind of. So we have baked into the attacker's perspective. Like, we thought how an attacker might use this data set to get into the open data ecosystem and extract those vulnerabilities. So if it fell into wrong hands, then obviously, they can use this. But that's why we are planning for a staged release. Like, the online version is the demo version, and we are planning for a staged release. Like, initially, we are only releasing it to the admins and university researchers before a public release. So we will put safeguards before a public release.
Awesome, thank you. So we got another question. What techniques do you use to identify disclosure? How could the tool accommodate other techniques, for example, differential privacy and inference attacks?
Yeah. So currently we are working only on identity and attribute disclosure. So there can be some other ways too. We are working on an improvement on this version. So we are planning to incorporate them.
So one other question from me is, what did you find the hardest thing about this project? It seems like it could be hard to evaluate given the sensitivity of the data and to validate it with having access to the right user populations and things like that. So what were your biggest challenges with this paper?
The biggest challenge was to create a generalizable workflow. Like, suppose you can download an open data set and do this thing. But how that can be generalized so that it applies to all data sets? So that was the hardest part. So we did like multiple iterations, like we did this, okay, this doesn't work. Okay, then we have to change our workflow. So finding out the correct workflow was the most difficult part of this project.
That makes sense. All right, I think that's it for our times for questions. So thank you again, Kostov. We really appreciate it. And with that, we will pull up our final pre-recorded paper talk, and this will be the final talk in this session from Maria and Hendrik. And then we'll have them on for questions after. So again, please use Slido to put in your questions for the authors.
Hello and welcome to the presentation of our paper, Visual Firewall Log Analysis at the border between analytical and appealing. My name is Maria Schuprin from Fraunhofer IGD in Germany, and I will present this paper together with Hendrik Lücke-Tieke and also on behalf of Jörn Kohlhammer. Well, first, let me introduce you to someone important. This is Peter. Peter is an information security officer. And this is Jan. Jan is a network analyst. They are both working at an IT provider organization. Of course, there are many other persons involved. Nevertheless, we have defined Peter and Jan as our two representative persona, which we created based on our collaboration with an IT provider organization. Peter and Jan are, together with others, responsible for the network analysis and security in their organization. And, well, we get to see a lot of data on a regular basis, especially a large amount of firewall logs, which we want to explore. Briefly, what are firewall logs? Firewall logs act as rule-based doorman as a guard against intruders. The firewall sees all incoming and outgoing connections. Thus, recording all denied and allowed connections leads to a valuable data set about activities on the network. This results in what we are calling the firewall log. A firewall log usually contains a source and a destination IP for each communication event, together with the timestamp and the performed action, for example, denied or accepted. Further, a firewall log can have several further attributes for each communication event. This format can be transformed in a list of unique IP addresses and their attributes. Now, Peter and Jan's special interest is to get more insight into these firewall logs and being able to draw more conclusion than before.
To achieve this goal, we conducted a multi-year design study in collaboration with an IT provider. Our contributions are structured according to the design study paper of Sedelmeier et al. First, we provide a problem characterization and abstraction for the design of firewall log analysis in organizations. Second, we present our visualization solution, consisting of two interlinked parts considering pragmatic and hedonic aspects. And as a reflection, we propose an extension of the information visualization design model to incorporate hedonic qualities. Three challenges were central in our design study: balancing conflicting requirements of several stakeholders, enabling flexible and interactive insights from firewall log analysis, and adequately integrating non-pragmatic, so-called hedonic aspects into the design process. During our design study, we conducted multiple interviews, meetings, and workshops with representatives from our collaborating organization. To elicit important information, we documented and analyzed the received input and feedback. We used personas as an inspiration and orientation, giving support throughout our design process. And in particular, we made use of psychological need cards as well as interaction vocabulary, which were researched and created by Hassenzahl and his HCI research group. These cards helped us with inspiration and with the validation of our ideas.
From our interviews, two clusters of interests and related stakeholders arose. We summarized them into strategical and operational interests. While the strategic cluster is interested in high-level overview and prevention and would like to see an easy-to-understand, intuitive and appealing interface, the operational cluster is more interested in low-level analysis tasks, in effective and flexible analysis, and is pleased with a technical demanding tool. We identified the information security officer and the network analyst as the key persons for the given problem statement and therefore created personas for these roles. For these personas, we created personal descriptions, and moreover, we identified key phrases from the interviews which best represents the requirements of each group and therefore the persona. For example, among others, a picture of the situation and aesthetical pleasing were significant statements of the information security officer. The network analyst side expressed a wish for a new type of analysis and a flexible interaction with data. Furthermore, we decided for a set of psychological needs which we thought best represented the stated requirements: security, stimulation, and a bit of popularity for the information security officer, and competence and autonomy for the network analyst.
We derived requirements and tasks based on our interviews, which were iteratively refined during the design process. For the group represented by the information security officer, it was important to get an insight into the firewall logs in an intuitive way. Furthermore, the wish to get a feeling regarding the picture of the current security situation within the scope of the recorded log was expressed. And finally, also being able to communicate selected issues in a comprehensive and appealing way to others. For the group represented by the network analyst, to expose suspicious activities on the network was as important as to examine the reason for suspicious behavior on network problems more closely, and finally, to be able to communicate selected issues in a comprehensive and detailed and accurate way to others. More details about the tasks belonging to these requirements you can find in our paper and in the supplementary material.
Here you can see an assignment of the tasks to the psychological needs. For example, get an insight into the firewall logs in an intuitive way, we have assigned to stimulation, as it is an act of exploration and curiosity. Expose suspicious activities on the network, on the other hand, goes along with a feeling of competence. We also defined abstract tasks for the requirements according to the taxonomy of Munzner. For details, please have a look at our supplementary material. Besides all this, we also decided for representative interaction vocabulary according to Lance et al. For the strategic cluster, we decided for fast, powerful, instant, inform, spatial proximity, and direct. Okay. So taking all this together for the strategic cluster represented by the Information Security Officer, we designed the cluster this. The main decisions were to use unit visualizations to represent the entities of the network. Further, to use units as circles, as round forms are known to be especially aesthetically pleasing. And the main functionality is to allow users to interactively divide units according to attributes and also to interactively explore communication behavior. More details on how the particular parts influenced our decisions you can find in the paper.
For the operational cluster, the chosen interaction vocabulary was powerful, fluent, and spatial proximity. Finally, for the operational cluster represented by the network analyst, a flow-based interface for interactive and flexible data analysis was chosen using the metaphor of a real-world whiteboard. Users can choose from a large set of analytical nodes and place them interactively and connect them on the whiteboard. Interactive visualizations, such as the cluster viz, can also be used as nodes.
While these two parts can be used as standalone applications, we are also meant to be interlinked and to work together. On the one hand, data exports can be exchanged between the two interfaces, and on the other hand, cluster this and other customized visualizations can be used as a visualization node directly inside of the whiteboard. Here we see the analysis starting in the whiteboard. Already many analytical nodes are connected to a pipeline. After selecting a dataset, an automatic anomaly detection is processed. The results can be displayed in a visualization, such as cluster viz. And also anomalies can be detected through manual visual analysis. Users can directly interact with the internally integrated cluster viz. But cluster viz can also be used standalone by dragging and dropping the respective firewall log file to the browser application. Existing IP addresses are displayed as circles. Anomalies are marked red. The nodes can be clustered according to existing attributes. Communication behavior can be explored interactively. The situation mode helps to instantly get an overview over the current situation.
To evaluate our solution and to receive feedback, we conducted several feedback loops during our design process. Further, we conducted 2 usability studies with students. As a highlight, we conducted a workshop around halftime where the network analyst, the information security officer, and a person from the firewall management team participated. The workshop included a hands-on task in a think aloud session and discussion. Finally, in a capstone event with the information security officer at the end of our collaboration, we gained further valuable feedback from a think aloud hands-on session and a follow-up discussion. Summarizing the main outcomes. The concept is perceived as appropriate and useful for the given goal. The implemented system and the individual parts are in general useful and engaging for the targeted audience. For a real-world application, improvements in stability, onboarding, and processing of larger data volumes are needed.
As a reflection, we have summarized the findings of our design process by extending the widely used design study framework by incorporating a hedonic track. Thereby, we oriented ourselves on the three first core steps of the design study framework of Siddelmeier et al. Usually, the analyze real-world stage is focused on understanding the usage context and identifying data user tasks. In the hedonic track, we propose to extend this part with the usage of psychological needs and definitions of personas to better consider the hedonic aspects. The stage design visualization system usually covers the visualization pipeline such as from Card and McKinley and decisions about the interface. We propose to extend the considerations through the incorporation of interaction vocabulary and a special focus on aesthetic design. And finally, for the validation step, we recommend to also include questionnaires targeting the hedonic qualities such as attractivity, psychological needs, and interaction experience beyond the perception and performance evaluations. Summing up, we have examined and presented the problem space for visual firewall log analysis in organizations, proposed the concept and prototypically implemented a system with two interlinked parts for high-level overview and low-level analysis tasks. And in particular, we considered hedonic aspects and psychological needs during our design process, and proposed a design pipeline for incorporating these aspects into the design process of information visualization. We hope that we did motivate you to look beyond a purely pragmatic design process and to rather consider the user's feeling in a new way. We want to thank you for listening and wish you all the best. Hello and welcome to the presentation of our paper,
let's thank our
Visual
speakers
Firewall Log
while we get the
Analysis
video killed.
at the border between...
Hopefully we can bring them up on Zoom. Can you hear us, Maria? Okay. Can you hear us?
Yeah.
Okay.
Do you hear me too?
We
Yeah,
can hear
okay,
you
great.
now, yeah. So
Okay,
firstly,
hello.
congratulations on the Best Paper Award at VizSec this year.
Thank you. Thank you, Stefano.
And we got a couple questions. The first one that we have is, were there any cases where you had conflicting design requirements, and how did you resolve those? I know part of your solution was to have this sort of dual visualization setup, but were there other cases?
Yes. So the main conflict is part of our paper. It's that one group wanted to have an interface with an overview and not so much details, but pleasing and good to communicate. And the other group wanted something to go more in details, and it was not so important that it looks good. And our main solution was to separate these parts, but also to interlink them. And with this, we have overcome many conflicts which would arise otherwise if we would try to combine this directly in one solution, because we could design the one part and the other part, and additionally, both parts can be adjusted. So if there will be other requirements which will come for a different group, we could adjust the different parts for its own, but combine it again.
Yeah, that makes sense. Another question we have is, what are the main trade-offs that you considered between usability, data interpretability, interface design, and visualization?
Yeah, there is some background sound. I don't know if it's already, it's like...
Okay, yeah, we don't hear that on our end, but...
You don't hear that? Okay, it's just here. Okay, so the trade-offs between usability, data interpretability, interface design, and visualization. Okay, so yeah, that's
a big question.
It's a good question, and it's a very wide question, I would say. Between visualization and interface design, maybe between user experience and visualization, this is quite interesting. For example, if you try to make a visualization look good, you have to use special colors which are engaging. But on the other hand, you have to pay attention that it's visually also makes sense. And I would say this is show one of these trade-offs that goes together with the usability. And yeah, in the whiteboard tool, we have the it makes it easy because it's just a flow, so you can use any data you want, and then the flow visualization is always the same. So it's a little bit to learn to get to the usability, but when you have got it, then you can use this tool very good with different visualizations. So this is also part of our solution, that we are not sticking to this cluster risk, for example, but you can use other which maybe are better fitting to other data or another question. Yes, so maybe something like this, but it's a really deep question.
Right.
I cannot answer this in 2 minutes.
Definitely. And I think we're out of time. So yeah, thank you very much for joining us. Congrats again.
Thank you, too. Thank you,
and
Chairman.
yeah, let's give our speaker one more round of applause.
Thank you. Bye. Good evening. Good day.
So we are at the end of our session, and we're only 2 minutes or so over, which I think is great. So just quickly, I want to plug that after the lunch break at 2 p.m., we'll be coming back in this room and seeing an expert panel on Zoom. We've got 5 people who all work in the space of security, human factors, visualization, that are all kind of in different situations, work at different places, located all over the place. So please come back for that, and then we'll talk about the best posters, and Chris will close out. So that's sort of what we have in store for the afternoon. So thank you, everybody, for joining us.